There is a humorous quote about standards. I mean, you can say standard is good, but I really like this quote, so I thought to bring some humor into this talk, that standards are like toothbrushes. It's good to have, but I don't want to use yours, right? So, one way or the other, chip industry has to deal with variety of chips. So far, I've heard my fellow engineers working at Intel or TI or some other places being very proud that I'm making the next generation CPU, or I'm developing the next generation ADC, or if it is the memory chip, oh, now we can put these many gigabits. I lost count. When I was doing it, it was 4K bits, right? But we are not making better of the same anymore. We'll have to deal with a variety of things. So essentially, industry has to find a way to deal with this variety explosion. A lot of people talked about design or manufacturing. Do you make, meaning you do manufacture only in India, or is design also important? So that's where I use the word do. Let's do things in India, right? And do it for the world. So it is very simple from that point of view. But to give a different perspective, if I'm going to have variety of gadgets, they will be all interconnected through whatever, it's like a Matrix movie, but instead of some remotely driven human beings, there is going to be remotely, if not driven, at least all interconnected things and people and all sorts of things, right? So in that world, when I look at product, it is very hard for me to even define it as a product or a service. I mean, just 2-3 days ago, Google surpassed in market cap to Apple. So now there is a services company that doesn't charge me anything for the services, right? And it has higher cap than a sort of actually product company. Would have vehemently argued 10 years ago that this can never happen, right? But it has happened. So in that world, I would urge you to break all the different boundaries that you may have used to kind of, channel your actually thinking. In that sense, when I get a service, maybe it is from one app, and I know there is a whole infrastructure behind it. The phone I use, whether it's Apple, iOS or Android and all that type of stuff. But to me, it has to be as appetizing as the dosa or the hamburger that I really like, right? And what makes that dish that I want to splurge on at that instant is lot of different things that all have to come together, right? We call some of those things software. We call some of the things hardware. We call some of the things design, some of the things manufacturing. But, and again, going back to Apple, iPod, they put everything together. And then you can say, well, their software was not better, their hardware was not better, their this thing was not better, then what was better? And since we don't have any better word, we say secret sauce. Okay, maybe their secret sauce. They had something, right? Steve, I just heard some interview where the guy was saying that Apple has lost that consumer touch. That anticipation of what will actually the consumer really like after Steve Jobs passed away. Whatever that is, but my actually proposition is don't think in this compartmentalized way. Because once we do that, we get trapped into scarcity mentality. We try to argue, no, design is more important or manufacturing is more important, right? They both are equally important. Software and hardware, and I'll talk a little bit more about it. There was an artificial boundary. For the last 2-3 decades, we had to use most of the chips that were available off the shelf. But that boundary is erasing, or it's kind of going away. It is becoming more actually porous. And that is the change, at least in a smaller way, that will be fundamental to at least what Sankalp does, and I would actually propose to most of the people here in the room, because we all are one way or the other focused on doing chips or hardware, right? So design and manufacture intertwined. Later on you will see Sankalp is trying to do manufacture aware design or manufacture conscious design. Similarly, I've heard people talk about design-led manufacturing. You cannot just do manufacturing where you are not aware and being able to cope with, let's say, if there is an explosion of devices, to deal with more than one device. Then your manufacturing plant is not of that much value, right? All right. So, unique thing about semiconductor industry. So now from global context, I am slowly coming down to semiconductor industry, right? So going back to the automobile example, and my thought process was also tuned to that, which is you do the design. You know, some guy in Italy, maybe sort of sipping wine, he just does some nice design for an automobile, sells it to Toyota or somebody, and they then work very hard and try to make a car. So the process in my mind was very simple. You design, then you manufacture all the different components, and then you assemble. But when you can put the entire system on a chip, I think the order of design, manufacture, assemble is actually getting topsy-turvy. What we do today, what we call chip design these days, is essentially we do the block design and then we assemble them on the chip. Once they are assembled, before we throw it to the like over the wall to manufacturing, to the semiconductor foundries, we have to be very careful because a single bug is going to haunt us. So we do verification that, in my opinion, we need to do verification that is more rigorous than validation, right? So essentially what we call chip design is really design, assembly and verification. So how can we do these three things in that order for variety of chips? That is really the challenge. We have mastered how do you do it for the same kind of chips, right? If I have to do the next CPU core, I know the team who had done it. I throw some more actually servers that are even higher speeds because I'll need more actually compute power. And I can say what the technology will allow me to do, how fast can I go from 10 gig to 20 gig, and boom, boom, boom. It was more or less like understood process. I think now we are going in the zone of not having well understood how will we cope with all these different things. So my submission here is we'll have to do four things. One is innovation. Innovation is a very widely used word. And here what I mean by innovation is not just a design innovation, because that is the first thing that comes to an engineer's mind. Yes, I can do 56 gig SerDes, but that is one type of innovation. We also need to think about innovation in automation, in our space, in the design space, innovation in verification, in our space, right? Things like that. Outsourcing. Collaboration to me really means, I think I really understood the meaning of word ecosystem in the last few years, right? You have to do your part well, understanding the broader context, and then cooperate with other folks, right? So outsourcing is mostly driven by just in time. Everybody has to get things out in a very short schedule, and to do that, it is a lot better to give that job to somebody. If you don't have to do everything, you just have to do one piece of the overall puzzle. Reuse, that's very obvious. And then cooperation or collaboration that I talked. How do you interweave these four elements into how you are doing things now? Because you can't throw away your existing model, which serves you well for your existing business. So you'll have to make continuous changes and adopt to how you will do things for this future emerging market. Right? So just little bit of IoT from my viewpoint. I would view the world, again going back to the Matrix movie analogy, there is some central nervous system that will do its thing, and for that it will need massively speedy actually computing power and whatnot. But talk about all the nodal things, which can be people, which could be things. So you want to build an IoT edge device that is residing somewhere on some nodal end of this massively complicated global interwoven network, right? And for that, it has its needs. You know, if it is remote, if it is in Bombay, then flood. If it is remote in Nepal or kind of Ladakh, then you'll have to kind of worry about those temperatures, whatever it is. And you've got an order that I need only 10,000, I can spend so much in NRE, and the price per chip cannot be more than this. And with all those sort of constraints, you have variety of condiments to choose from to make your hamburger or your dosa. You can choose your CPU, you can choose your interface, you can choose your OS and all that type of stuff, right? So you get the idea. So I would like to coin a new word. You know, we had talked about ASIC since the IBM was the ASIC king, and then LSIs and Toshibas and all came, and then eSilicons and open silicons, but those were application-specific ICs, not really full systems. So then we coined the word SoC, and those were SoCs for massive markets like cell phones and whatnot. So they were SoCs, but they were not, I mean, they were application-specific, but few guys would do it, right? So how about SOC? Application-specific systems on chip. And that I think in my mind describes a variety lot better. It will be really application-specific, various systems on chip, because you can do so much on a chip, given all the different process options you have. So application-specific system on a chip, SOC. The beautiful thing is, these SOCs, or at least 90% of these SOCs, anybody can make. Now anybody, meaning I'm not indicating that a commerce graduate can do it by himself, but you don't need to have a fab. You can do the contract fabrication. You can do contract manufacturing. You don't need to be an expert on the CPU. I mean, you know, 20 years ago, if my friend bought a new PC, I'll say, how fast is the CPU and how much memory, right? Now, as a chip designer, I have a choice to put whatever CPU I want and whatever amount of memory I want, and maybe throw a few more things in, wireless, wired, interfaces, some analog functions like, you know, power management, this and that, and I got the chip that I want. So chip making has been really democratized. In that sense, you can say hardware is becoming like software, right? That doesn't mean that anybody can do iOS tomorrow. I mean, that wasn't, that is obvious to everybody in the software industry. So equivalently, everybody cannot do the unseat ARM tomorrow, or can do better analog chips than actually TI. But there is an equal opportunity to do at least some chip somewhere, or at least make it for somebody who knows what he wants. So again, if you don't go for branding, if you go with the Foxconn or the TSMC concept, you make for whoever wants it the factory concept to the chip design, then from that viewpoint, we all can build a factory where we can do all this kind of variety of chips, right? All right. So far I talked about industry. Now a little bit about India. So my view on India, we are in the third generation of free India, independent India. And from semiconductor industry, we are in the second generation. And here each generation I'm counting about 25 years, right? You can say in the old days it could be 20, but now slowly it is stretching. And some of the things that I've observed now that for the last 10 years that I'm interacting a lot more is one is actually the sort of content of what we talk in forums like this. Just 4 months ago, I was in a forum called Global Business Forum, organized by IIT Bombay alumni. And they brought government, academia, industry, venture capitalists all under one roof. This is another example of that, right? We have a lot of different players. I mean, we talked about Foxconn on one end, and Seagate, and the large services providers like Cyient, and all kinds of people all came together, right? So this is some data, and now the timing one can actually question, but general trend I would agree to, which says that if you look at Fortune 500 companies worldwide, the global Fortune 500 companies, and where they are headquartered,